Well, hello, good afternoon everyone. I hope you're enjoying DevWeek. Just a day and a half left, or less if you're not counting the workshops tomorrow. This is a talk on iOS development, an introduction that doesn't assume any prior knowledge of the language, the development tools, the platform itself. It is useful if you have an iPhone or iPad at home, in the office, so that you can apply some of the things we learned here. And of course, if you have a Mac as well for your development itself. But again, I'm not assuming anything about your background. This is good for .NET developers, for C++ developers, and we will cover a bit of the language itself, Objective-C, which can be a bit hard to read at times and write as well. So I'm Sasha Goldshtein. I work at a company called Segues. We do training and consulting, and I'm really glad and happy to be here at DevWeek for the second time. And I hope you've seen some of my other talks. If not, they're all recorded, as you know. I had a talk in C++ and TPL. I have an Android workshop tomorrow, just selling my other talks. Anyway, let's get started with our first step in iOS development. And the first thing I'd like to talk to you about is the iOS platform ecosystem, what we're building on, essentially. So at the top, there are some 900,000 active apps. And active apps here is defined as apps that someone actually has installed, that are being downloaded. And there's quite a significant portion of apps in the iOS App Store which have never been downloaded even once. So this, no, seriously, I mean, maybe by their developers, but no one else. And so this number here is pretty impressive, and on the one hand, it looks like the store is totally saturated with apps, and on the other hand, you can still see people making lots and lots of money off the App Store. And so whether you're going to build a business app or a very cool game or some productivity application or a business application, you're joining a bunch of people who are really making money off this market. Below the apps themselves, we have a few frameworks which I'd like to mention. The first layer, which all of our apps are going to be accessing, is called Cocoa Touch. And it's fairly similar to what you'd have on the OS X desktop. The APIs here are stuff like UI, motion manipulation, gestures, animations, stuff like that. And again, it's similar but not identical to what you'd have on the Mac desktop. But again, the ideas, the names of various classes, the concepts are pretty much the same. Below this layer of Cocoa Touch, which mostly again deals with the user-facing aspects of your application, you have another layer called core services. And core services are stuff like low-level graphics, hardware support like sensors, like the gyro, the accelerometer, the GPS, the Wi-Fi. Threading as well is inside this layer. And in the core services layer, there's really great parity, API parity between iOS, iPad, and iPhone, and the Mac desktop. So again, if you're considering porting code from the Mac to iOS or from iOS back to OS X, it's going to be easier. At least some of the APIs are virtually identical. And finally, below all of these layers, we have the kernel called Darwin, which is a shared kernel, exactly the same kernel that OS X uses, which was originally based on OpenBSD, FreeBSD, and this layer isn't really accessible to applications. This is where drivers live, this is where the security model of the system is implemented, and so again, we don't have APIs that we can call into the kernel directly, and we cannot extend the kernel on iOS. The system is really closed, both the hardware and the operating system, as you know, are provided by Apple. So we're going to focus, of course, on the apps layer and touch some APIs from Cocoa Touch. We're not going to go anywhere inside the core services layer, at least not in this talk. Now, in terms of the platform philosophy, there's just a couple of things I'd like to tell you about before we actually move on to devices and code. And so, from the user's perspective, the one major thing that Apple is pushing is to be consistent. And there's a set of very, very strict design guidelines for designing human user interfaces for iOS. It's a pretty long document, and unlike other user interface design documents, this is a document that you actually have to read and you have to adhere to because Apple will verify that your application meets these guidelines. And there's stuff like the distance between the two buttons must be at least 33 pixels. And so it's really down to that very, very detailed level. And again, the idea is that apps feel consistent with the platform. There are some basic tenets which are never violated. The user feels at home on any device. And of course, there are many experiences which are seamless, like purchasing applications, like transferring applications from one device to another, like backing up your device. So again, Apple is really pushing towards taking all these concerns and handling them for you, so you as app developers really don't have to think about getting your apps onto the device. You just have to be a great app once you're on their device. From the developer's perspective, the development environment, the language, the tools, the APIs, the frameworks, they're all very object-oriented. Objective-C is a very, very object-oriented language. So we've got classes, methods, protocols, which are sort of like interfaces. We'll mention a few of these concepts a bit later. There is just one major language that Apple supports officially and pushes as the official development language for iOS, and that's Objective-C. Of course, you can write iOS apps in JavaScript. As you all know, there's a bunch of frameworks like PhoneGap, which allow you to build JavaScript and HTML applications for iOS. But this is not what we're going to be doing here. I want to target the native layer, and JavaScript applications are essentially just a web browser window that's hosted inside a native app. So we're going to focus on native apps here. And in the UI framework itself, inside Cocoa Touch, there is a very strong push towards separation of concerns, towards an MVC, a sort of traditional 1970s MVC architecture, and in iOS it's still going very strong. And so you'll see views and controllers and models in every aspect of your iOS application. And finally, from Apple's perspective, Apple have full control over the software ecosystem, over the hardware ecosystem as well. The devices are controlled by Apple. Apple builds them from parts, well, assembles them using some other vendors, but essentially they control the whole pipeline and they control the software. You can't install, any other operating system on your iPhone. You can jailbreak your iPhone, you can modify it in some unsupported ways, but from Apple's perspective, they really control the whole ecosystem. And they are, and this is another important part, the ultimate arbitrator on whether an app goes into the App Store. And there are many horror stories of developers waking up one morning and discovering that Apple, in the new iOS version, have basically implemented their app. And so now these developers are out of business because their app is now provided by Apple, and they can't even submit their app again into the App Store because now it conflicts with a built-in Apple application, which was second to the store, but it doesn't matter. So Apple is really very draconian in terms of what goes into the App Store, and there are many disappointed developers who have seen these conflicts with Apple, but it's still, again, a very well-paying market. So, once we have this platform philosophy of business out of the way, let's talk a bit about the devices and the operating system versions, which is quite important even in this introductory talk. So, in terms of devices, I haven't put all the various iOS devices here. This chart starts with iPhone 3GS, which was released in 2009, almost 5 years ago. And then there's the original iPad, the iPhone 4, the iPhone 4S, the iPhone 5, and the iPhone 5C and 5S, which were released just late last year. And in terms of operating system versions, well, the 3GS shipped with iOS 3, the iPhone 4 shipped with iOS 5, iPhone 5 with iOS 6, and iPhone 5C and 5S with iOS 7. So there's evolution of the operating system versions as well as the devices themselves, but it doesn't always go hand in hand. Apple have released OS versions without a new device and have released new devices without updating the operating system version. The interesting part about this is that even though there are 7 major iOS versions in the version history documents, you really shouldn't care about 7 iOS versions today. Because as of March, 83% of iOS devices already run iOS 7. And that's less than 6 months after iOS 7 was publicly available. And the full statistics are that 83% of devices run iOS 7, 13 or 14% run iOS 6, and the remaining 3 or 4% run older iOS versions. And so if you're developing a new app, you might as well target iOS 7 and just not support any older versions. If you're targeting very broad coverage, like if you're Facebook or Twitter and you have an app that's going to be installed on millions and millions of devices, you might consider targeting iOS 6 as well. But older iOS versions, anything basically that was released more than a year and a half, 2 years ago, you really can discard and not target. And this is pretty amazing because it means you get to take advantage of all the new APIs that Apple is introducing. You don't have to wait for all the users, for 3 or 4 years to pass until all the users have finally moved on to the latest iOS version, which by then is not latest. It really happens very, very quickly. And this makes lives, for our lives as developers, much easier in terms of OS versions. There's a similar story, which also makes our life easy in terms of the various device sizes and screen resolutions. And this is again interesting because if you look at Android, for example, there are literally thousands of Android devices with various shapes and sizes and screen densities and resolutions. And it's really super hard to build a UI that will even look decent on all of these devices. In the iOS world, on the other hand, you basically have 3 resolutions to support. You could even say you only have 2 resolutions to support. In the smaller device world, in the iPhone world, you have the original 3GS resolution, which is 320 by 480. You have the double Retina resolution from iPhone 4 and 4S. And again, it's sort of the same resolution, but it's at a higher density display. And so you just scale your images twofold in each direction. And that's basically all you have to do to support these new high resolution displays. And on the iPhone 4, you have some more pixels vertically. So it's 640 by 1136. And again, it's pretty easy to take advantage of these extra vertical pixels by using a system called Auto Layout, which is a feature of the development tools that will stretch your UI accordingly. So on the iPhone, you could say you only have 1 or 2 resolutions to care about. And on the iPads, the various iPads, again, you have the 1024 by 768 resolution from the original iPads and from the original iPad mini. And then you have the Retina resolution from iPad 3, 4, and the Retina iPad mini, which is again exactly double the 1024 by 768. So again, you only have 1 resolution that you really have to care about. And of course, as a big iOS development shop, you can afford to actually have all of these devices for testing. It's only 6, 7 devices to have in your lab. Whereas with Android, again, you have thousands of devices and no one can seriously afford to have them all in their lab. So I'm telling you all of this so that you know that once you get into the iOS ecosystem, the fact that Apple controls everything can sometimes actually make things easier, both on the device sizes and resolutions aspect, and on the OS, which is totally controlled and users move forward with OS versions very rapidly. So with that said, let's take a look at the development tools and Objective-C first, which is the development language. So in developing for iOS, the development tool itself, the development environment that we're going to be using is called Xcode. This is a full IDE, integrated development environment, which only runs on Mac. So you do need a Mac for iOS development. And this is the primary reason, because Xcode only runs on Mac. Objective-C is the development language that we'll be looking at. And finally, UIKit is the framework inside Cocoa Touch where most of the UI controls live. Stuff like buttons, sliders, segmented controls, text fields, these live in UIKit. And this is the part of the library that we're going to be doing most of our interaction with. So let's start with the language, Objective-C. And this is going to be a really quick tour of Objective-C. The primary reason being that in the demo, we won't have like super complex Objective-C classes, so I'm only going to show you here in the slides the things that I absolutely need for the demo. But generally Objective-C is a programming language, and it usually takes more than 10 minutes to learn a new programming language. So, Objective-C classes are pretty similar to classes in other programming languages like C#, C++, what have you. Like C++, Objective-C classes are declared in a header file and implemented in an implementation file. So the header files are H files and implementation files are M files. You also have keywords for declaring the part of the declaration, which is called the interface, and the part of the implementation, which is called the implementation. And so here we have a class called myClass, which derives from NSObject, which is a very common base class. You don't have to use it, but lots of services you get from the Objective-C runtime depend on you deriving from NSObject, and so it's a useful base class to use. And it's an empty interface, there's nothing inside, so no methods, no fields, no properties, nothing. And then in the M file, in the implementation file, we import the header file. So import is like C++ or C's include directive. And then we provide the implementation for that class, which is empty. Now you could put both of them in the same file, but it's really common to split your headers and implementations. Okay, so this is an empty class. Let's add something to our class. Let's add methods. And this is one of the ugliest parts of Objective-C when you see it for the first time. So these are three method declarations on a class called cat. The first one is called meow and returns void taking no parameters. This little dash over here says it's an instance method as opposed to a static method. A static method would have a plus sign over here instead of a dash. So dash is an instance method, a plus is a static method. And then we have another method which returns a boolean called does like other cat. And this method takes one parameter of type cat star, pointer to a cat, and the parameter is called other. So again, this is really this funky syntax of putting your parameters after the function name, and we'll see more of this later. And then finally, we have this method called age, which returns an int. And then we have implementations for those. In the implementation file, the meow function, the meow method, prints out a statement to the console, to the log. We're using the nslog function, which is a global. The age function, the age method, simply returns 7. And then does like other cat is a bit different. It takes a cat object, and then it wants to check that other cat's age, because we only like cats who are older than us for some reason. And so what we do here is an if. If self age is less than or equal other age, then we return yes, which is true. Otherwise, we return no. And so these brackets over here and over here are just the method call, method invocation syntax. This is the receiver, and this is the method. This is the receiver, and this is the method. And self, of course, is this object. Okay, so we have methods, right? Methods are useful. Next thing we need, there's also this little thing over here, which is a nice piece of Objective-C. What happens here if other is nil? What if I pass a null cat to this doesn't like other cat method? In every other programming language like C++, C#, and so on, when you try to call a method on a null reference or a null pointer, you will get an exception, right? Objective-C takes a more message passing approach. If you send a message to a non-existing receiver, then you get some default value back. There is no exception. And so in Objective-C, if I call the age method on a null or a nil receiver, I simply get 0 as the age. And if I ask a nil cat, if this nil cat likes some other cat, then I will get no as the answer. Because again, this is the default for Boolean methods. This is a bit weird, but you can get used to it. And when you do get used to it, you can start using this to your advantage, because it means you can use fewer ifs, fewer checks in your code. In some situations, this default value is really what you wanted anyway. And so you can just sort of use that in your conditional statements. But at first, it surely is a bit surprising. All right, next thing we need are initializers and fields. So we can embed fields inside our classes, of course. And this here is a public field, which is pretty much frowned upon in Objective-C, as in other object-oriented languages. And so this public field is called age and underscore. And we also have a method called initWithAge, which takes an int called age. And it returns ID, which I'd rather not explain in detail right now, but it's suffice to say that ID is pretty much any object. It's sort of this undefined type that you can pass through arbitrary objects as ID. So if you have a variable of type ID, it can accept any object. And if a function returns ID, it means it can return any object. And there is a good reason for this being ID here, but let's not get into this just yet. And so in the implementation, we need to implement initWithAge so that it initializes this public field. And the way we do that is as follows. Inside initWithAge, we call a function on the superclass called init. And that's part of NSObject. So we have this init method. I call it and get back, well, an initialized object, which I oddly assign to self. So part of the object's initialization is actually initializing this pointer, which is called self. Again, a bit weird, but this is the way in Objective-C of initializing anything. And so if this initialization was successful, then self is not nil, and then we can assign the age field to the parameter's value. Otherwise, or actually in any case, we return self. And so if initWithAge returns nil, then initialization has failed. If initWithAge returns a valid object, then initialization was completely successful. And so, yes, initialization methods, initializers, can simply return nil. They don't have to throw exceptions or anything to indicate that they have failed. And in fact, there are quite a few places in the Objective-C runtime where exceptions are used. In many, many cases, methods simply return some special return value, return code to indicate failure and will not throw exceptions. Exceptions are really reserved for super exceptional situations. So we have initializers. Last thing we need from the language itself are properties. And properties, again, are an extension of this C-ish syntax because, you know, C++, for example, does not have properties. Java does not have properties, but C# definitely does have properties. And so properties in Objective-C are a bit similar to properties in C#. Essentially, it's a wrapper for a couple of methods. A property wraps a get method and a set method. And in many, many cases, you don't have to actually implement these methods yourself. By saying that part of your interface is a property, using this @property keyword, you now have both a getter and a setter for a property called age, and you also have a private instance field inside your class called _age. So by just saying this, and this, by the way, is true only as of iOS 5, maybe, I think. As of iOS 5, this property syntax will declare this backing field for you and will declare a getter and a setter for you. So you just write this. And then inside your code, inside the class, you can access this backing field, _age. Outside the class, you use this age property like you would use a field. So it's not the method call, you actually use it with the dot notation, which will be on the following slide. So properties are really handy, and they are nothing but wrappers for getters and setters. And so here's an example of using objects that we've needed to, sort of wrap this thing up. I create a couple of cats in the following manner. First, we call a method called alloc on the cat class. So this is a static method. And we call it to allocate an object of type cat. And then we have to initialize that object because it's just, a plain block of memory. InitWithAge will initialize that object and return a valid initialized cat, the cat star. And so we have a couple of cats. And then I can ask, well, does Felix like shadow? And so if Felix likes shadow, then we can do something else. And then I can also do stuff like if, maybe there's some calendar class which has a method, a static method, is birthday, and then I can check if it's Shadow's birthday today. And if it is Shadow's birthday, then I can access the age property like this. So this is the dot syntax for properties. Shadow.age++. And this will call the getter, increment value, and then call the setter all in one line, which is obviously more convenient than calling a couple of methods for this. There's more weird syntax in this slide, and I know what you're probably looking at. You're probably looking at this weird thing over here. We might see a couple of examples of this in code. And again, I'm not trying to give you a tour of the whole language, just some samples so you can understand the code we're going to be working with later. So now that we have this tour of Objective-C complete, there's just one thing worth mentioning, which changed, well, quite a few years ago, but it's still worth understanding regarding Objective-C memory management. So Objective-C does not have a garbage collector. And Objective-C does not have a garbage collector on OS X, even though it used to have one. And it doesn't have a garbage collector on iOS, and it never used to have one. So there's no magic, leprechauns that will collect memory for you if you just fail to deallocate objects. However, as of iOS 4, there is a compiler-provided feature called ARC, Automatic Memory Management. And ARC sort of magically releases memory for you. And it's based on reference counting. So your Objective-C objects, the stuff you allocate off the heap, your Objective-C objects have a reference count embedded in them. And that's the number of references active still pointing to that object. And once that reaches 0, the object is deleted. But the compiler manages this reference count for you. It will increment and decrement the reference count when you perform operations on objects, like assigning a reference to some other field, clearing out a field, passing an object as a parameter to a function. In all of these cases, the compiler takes care of embedding this memory management for you. And it means that, at least when you're getting started, you don't have to think about memory management at all. There are some situations, like when cycles are involved, A points to B, B points to A, when you do have to do something explicitly to break these cycles. But in many, many cases, the compiler just takes care of memory management for you. And so all you have to think about is just allocating objects and not exactly when they're deallocated. And also, the development tools have really great static and dynamic code analysis features for detecting memory leaks that you inadvertently write and fixing them for you, or at least suggesting how to fix them. So the memory management story is really great for a language that does not have garbage collection and never had a garbage collector on iOS. So this was Objective-C. If you do have any questions on Objective-C, this would be a good time to ask.
H underscore, not underscore H, but H underscore.
Oh yeah, that's just me showing you a couple of conventions. But when the compiler generates a field from a property, it will be called underscore H.
Yeah, but there was also H underscore.
Yeah, and that's again me
Is
just
this
me.
the same? Or
No, it's not the same. It's just me showing you that you can declare a public instance field.
all right.
Right? It's just a matter of convention.
Do we do crazy one?
I'm sorry?
The calendar, the one with about 5 things,
Yeah.
with all the square braces.
All right. Yes. Okay. Yeah. So this one I deliberately skipped, and this is basically a method. Yeah. This is a method that simply has 2 parameters, and this is the syntax for passing 2 parameters to a method. So the first parameter is called isBirthday.
So it's like the label thing in C#, so that's the label thing on the bus.
It's a bit similar to named parameters in C#, yes, except in Objective-C you always have to use this syntax. So the method's name is actually isBirthdayOnDate, including the columns. If you look at the documentation, it will say this method is called isBirthday:_onDate:. It's an Objective-C
language.
Well, yeah, initially language.
Predates C++.
Yeah, we might see an example of this later, but again, it's really something you get used to and you read this thing without even thinking about it. And it does read more like English. I mean, calendar is birthday shadow on date today. It's closer to, is shadow's birthday today than the C++ or C# version. So that's probably the motivation here. Anyways, okay. So let's move on to our first iOS application. And the only thing I'm going to do in this demo is just walk you through the File New Project wizard and run the result. And then we'll talk about the project structure that was generated for us. So we're moving to the development tools part of the talk. So the development tool that we're going to be using is Xcode. There's quite a few versions of Xcode. You typically have to update to the newest version of Xcode to develop for the latest version of iOS. The good news is that Xcode is free. And so if you have a Mac, which is not free, then you can definitely install Xcode for free from the Apple App Store on the Mac. And so we're going to create a new project. And now I have this nice template wizard, which asks me to choose a template for my new project. And there's a few options here. We're going to go with single view application for now, which is an application that only has a single screen. We can add more screens later. It's just a matter of what the template generates for me. There's more options here, like a master detail application, like the email app or the messages app, which have several screens, master detail. There's a tabbed application, like Twitter, which has tabs on the bottom. We also have a couple of game templates, and these templates are for iOS applications. You can also develop OS 10 desktop apps with Xcode. So I'm going to go with single view application. Next thing it asks is the product name, organization name, company identifier. I'm going to call this thing OneNote because it's going to be an app into which you can input some text, and I could call it a Notes app, but it will only have room for one note, so I'm going to call it OneNote. And then the rest of the details aren't quite as important. Towards the end, I can choose the devices on which I want this app to run. And so I can say iPhone, and that's going to be an iPhone-only app. I can say iPad, and it will be an iPad-only app. Or I could say Universal, and then the same binary, the very same application, will be deployable to iPads and iPhones, both. It does mean that you have to adapt your UI, but the code, your business logic, can stay exactly the same. And this is, again, pretty compelling. You do have pretty much the same story with Android today. You're going to have a single package which will run on tablets and phones. And we probably will have, or already have, a similar story with Windows Phone and Windows 8, just announced and built. And so I'm going to go with iPhone for now. This will ask me where to create this project. And then we have the main Xcode screen. I'm going to zoom in on a few parts for the ones in the back. So on the left, I have this package navigator, which basically shows me all my files. And again, I'm going to talk about the files a bit later. In the middle over here, I have the main area, which is where I can edit my app's details. On the right, I have this area, which hosts a bunch of inspectors. Inspectors are basically property panes, which show you various data about whatever you have selected elsewhere. And finally, these buttons over here are pretty important because they help you, customize what's shown on the screen. And so I can have multiple panes popping up and down. Xcode is super not extensible and super not configurable. So, for example, if you really would rather have this package thing on the right, you cannot. Okay? It has to be on the left. You can see the Apple philosophy just sort of shining through this. Okay, so now we have this app. I'm going to run it using this big run button. And this will launch a simulator for me, the iOS simulator for running my app. This is the iOS simulator. It took about 3 seconds to launch, right? And the reason it's so fast to launch is that it's not a full operating system image using an ARM processor like the actual iPhone. This is a custom build of parts of iOS for Intel CPUs. So it's not really the target system that you'll be running your code on. It's, you could say, a virtual machine that's running on your native hardware. And so it's much, much faster than the iPhone. So you shouldn't read anything into the fact that your app is fast and fluid on the simulator. You really do have to use an actual device. Anyway, our app was pretty fast. It launched and it's empty. Just to show you the simulator itself, I can go to the home screen and I've got Safari down there, and I have the main page here as well, and I have contacts and settings and calendar and maps, and these apps are pretty functional actually. You can even add accounts and send emails from your simulator, read email on your simulator. And of course you have various simulators for various versions of iOS and for various screen sizes. This one here is iPhone Retina 3.5 inch running iOS 7. And so you can have multiple configurations like that. Right. So we have this app running. Before we actually do anything with this user interface, I want to just go over the few major generated files that this template produced for us. And the slide has it in bigger fonts. So the first couple of files that the template generated for us are the application delegate. And if you're using WPF or Windows Phone, this is sort of your app XAML class, the app class. This is where the system interacts with your application and not a particular screen. So the application delegate is a class that's responsible for initializing the app when it's launched, for putting it in the background, for restoring state, various work like that that's global to your app. And then we have the view controller, H and M files. A view controller is a controller. So you have this one view, this one screen in your app, you have a view controller class to manage it, to back it. And so we only have one class as well. Then we have the storyboard, right over here, main storyboard.storyboard. A storyboard is where you define your application's user interface. It's called a storyboard for various reasons. Apple wanted this weird terminology there. The storyboard has scenes. Each scene is a view, and then you have transitions between scenes. And so this whole thing is called storyboard. But this is basically where you define your application's UI. And we're going to work with the storyboard in like 30 seconds. And then we have some supporting files. A property list, localizable strings, application icons. There's a bunch of additional stuff that you can have there. Localization, for example, mostly involves creating various versions, multiple copies of this strings file with strings in the appropriate language. And so there is a localization story built into the template. The property list for your application has this various details like the name and version of your app. So we have a bunch of files. We have this storyboard concept. Let's talk about MVC for 1 second and then jump in to add some code. So in the iOS MVC architecture, or the thing that Apple forces on you, there are three major concepts: views, view controllers, and model classes. Views, of course, draw themselves on screen. They don't understand anything about your business layer. They might have properties of type int or string or double, but they typically don't know anything about your actual classes or actual business classes. And of course, views, there's a bunch of views provided by Apple. Views like, again, buttons and tables and sliders. And view is also the general term for a whole screen full of views. So a view can, of course, contain additional subviews like any other UI thing. The view controller is the thing that creates and coordinates views. It receives information from views like events, and it reacts by changing properties on these views. Again, pretty much like any other controller. And finally, the model or UI agnostic classes can be just a bunch of stuff, JSON files that you download from the internet. It can be a database that you read from using an object relational mapper. It could be classes you create in memory. There's a bunch of frameworks for managing your models in iOS in various ways, which we will not look at here. So let's build a simple UI and then connect it to code. So I'm clicking our main storyboard file over here, and this opens this beautiful designer where I can edit my user interface. I'm just going to make it a bit shorter. I can switch between 4-inch and 3.5-inch screens, and this is just more readable at this resolution. Now, I'm going to make this thing go away and make this thing appear and drag this over here. And so now we have this basic scene, which I can move around, and we have a bunch of views that I can drag in from the toolbox. So the first thing I'm going to drag from the toolbox is a label. I'm going to position this label right over here, and you should note that I have this alignment guide, right? Which tells me this is going to be right in the middle, horizontally. And I'm going to change the text on this label to read note title. And now it's no longer horizontally aligned, so I'm going to horizontally align it again. Now there is a good reason for me doing this. If I run the app right now, well, obviously it appears in the middle. But then if I rotate to a different orientation, you'll note it's no longer horizontally centered. And so I have some layout problems with the way I have defined this, the way I've positioned this label. And again, we're not going to talk about auto layout here, but auto layout basically is the system that manages positioning of views in a dynamic fashion where screen orientation or size will change. And so, for example, in the editor menu, I can say editor align horizontal center in container. And then I have this other alignment guide that appears, and this is there for good. And so if I rotate now, it's going to be right in the middle. So again, this is pretty much all I have time for in terms of showing you auto layout, but there's much, much more, of course. You can align views to each other. You can say this view is going to end where the previous view begins, and so on and so forth. Okay, so we have the note title label on screen. Let's add a text field, which is going to be the actual title. Let's drag it to the alignment bars over there. And then I'm going to have another thing over here called a text view, which is essentially a multi-line editable display for text. And well, it's got a bunch of text in it, so I'm just going to delete this whole thing. And well, I might also want to give it a background, so the user will actually know there's a field there. So over here on the right, I can change the background to something like this. So if I run this app, okay, well, I'm not sure this really looks editable, but it is editable, absolutely editable. And this thing over here is editable as well. And so this is the basic UI for our app for now. Now, again, it's not connected to any code, right? We've just built this thing in the storyboard, and the next thing we're going to have to do is connect this view to its underlying view controller. And so there are again two new terms here, outlets and actions. This is how you connect views to view controllers. An outlet is simply a property on the view controller which is connected to the view. And the view can use that property, the view controller can use that property to manipulate the view. Retrieve text, change text, move the view, make the view disappear, add additional views to the view. So an outlet is just a reference from the view controller to the view. An action, on the other hand, is an event handler. It's a method on the view controller, which is called when something interesting happens to the view. So when a button is clicked, you can have an action, a method called on your view controller. Again, weird terms, outlets and actions, but that's just the way Xcode expects you to connect views to view controllers. And yes, it's actually something that Xcode expects from you. There's a couple of keywords, IB outlet and IB action, which only Xcode requires. These keywords are defined as nothing particularly interesting for Objective-C, but Xcode needs them to recognize an outlet and to recognize an action. So let's take a look at an example. So I have this text field here, and clearly I'm going to need my code behind to access it, to save the note's title, manipulate it, whatever. And so I'm going to use this button over here, the butler icon, and this is the assistant editor. If I click this, then I have a side-by-side view of my view controller's code and of my storyboard. And again, there's a very good reason for this. But take a look at the code first. This is the implementation file, the M file, for my initial view controller, which is originally called view controller. And so this is the implementation. It has a couple of functions which I will remove right now. We don't need them yet. And what I do want to do is create this connection between the text field and the view controller. And here's how you do it the Apple way. Let me just zoom in a bit. You control drag from the text field to the view controller source file. Control drag and release. And then it says, oh yeah, sure. You want to create an outlet on the view controller of type UI text field, which is the type of that text field. And what do you want to call it? So I can create it for you. So let's call this thing node title. And then it just went ahead and generated a property of type UI text field star called node title. And it's connected to this text field. And the way you know it's connected is by looking at this gray thing over here, this gray circle. You can see that when I hover over this gray circle, the text field gets highlighted. Right? Beautiful. And so now we have this connection between the text field and the view controller. And I can do the same thing for the text view. Let's call it node text. And so now we have two outlets, and we can use them from the view controller to manipulate the view, to change the title, to change the text, to retrieve it, and so on. The other thing I want to do is provide a save button, so the user can save their changes to the node's title and text. So I'm going to go back to the storyboard, open the library again, and pick a button from this list. This is a button. In iOS 7, a button no longer looks like a button. It just looks like a link, basically. So this is a button. Not very good positioning for this button, but let's just keep it there for now. And let's change its text to save. So this is a button, yes, because it's blue. Now, for the button, I will need the view controller to react to whenever the button is getting tapped. So, we're going to open the assistant editor again, drag this over here, zoom in a bit, and again, I'm going to control drag from the button to the implementation section, which is where I can add methods. So I control drag and release, and it says, oh yeah, sure, you want to create an action this time on the view controller, give it a name, and you should also specify the event. What should trigger this action? What should trigger this method? So the name is going to be save, and the event, well, here's the list of events I can use. Touch up inside is the default. And how does touch up inside make sense? Why touch up inside?
You're releasing your touch inside. Yeah, so that's the up.
Right, so the user touched the button, and then while inside the button, they release their touch. Right, so touch up inside sounds weird, but that's what we want really. And I'm going to click connect, and then we get an action right here. It's simply a method called save, which returns IB action, but IB action is actually defined as void, so this is a void method. And it takes a sender, which is the thing that sent this action, and in our case, it's going to be the button, of course. Now, inside this method, I'm going to do a very simple thing for now. I'm just going to go ahead and log the updated task. So I'm going to do this updated task, title, text, and I'm going to pass in self.nodeTitle.text and self.nodeText.text. So the first string over here is just a format string for NSLog. So I have two format specifiers, and then the strings themselves that I'm printing out are obtained from the outlets that we have declared previously. So UI text field has a text property, UI text view also has a text property, so this is how I can grab them and display them. So if we run this thing now, it's going to be pretty functional, of course not for the user, but for anyone who can see the console. So if I change the title to Buy Flowers and the detail to Do It Now, and then click Save, then, too much zoom. You can notice that at the bottom of my Xcode window, let me zoom in a little more. At the bottom of my Xcode window, I have this output, updated task, title, Buy Flowers, text, Do It Now. So we have this connection between the view and the code. Now, there is a little problem here, which gives me an opportunity to demonstrate another aspect of iOS. If you look at the simulator now, there is no way for the user to hide this keyboard. Seriously. I mean, I can move between the two fields, and then the keyboard is still shown. I can try clicking on other areas of my app, but nothing happens. I can even click Save, but again, it doesn't make the keyboard go away. And finally, I might even try and hit Return on that keyboard, but it's still sticky. Well, you could say it's a feature, right? The only two things that can have input focus are the text field and the text view. And so once one of them has input focus, well, one of them is always going to have input focus. So we need to do something active to remove input focus from one of these windows so that the keyboard will go away. There's a few ways of doing this, and I want to show you a cool one. Users often expect that when you click the background, the keyboard will go away, right? I mean, it's a pretty common paradigm. You click the background, the keyboard goes away. How will we detect that the background was clicked? So, you know, we could say, oh, I'm going to place a big view behind all my other views and put an action on that view. And, I mean, that used to be the right approach, ridiculously. But now, I think as of iOS 5, we have a slightly better alternative called gesture recognizers. There is a gesture recognition framework that you can tap into, and you can detect a bunch of UI gestures, like taps, swipes, zoom and pinch gestures. And so this is what I'm going to do here. I'm going to open the storyboard again, open the library, and from the library, I'm going to find a UI gesture recognizer over here. So a tap gesture recognizer is what we need. We need to detect a tap on the background. So I'm going to grab this gesture recognizer and drag it to my view. Add. Okay? And now it's there. So it will recognize tap gestures, except I don't see it anywhere, so it's kind of hard to do anything with it. It is shown down here. There's this tap gesture recognizer button down here. Or I could switch to the outline view using this button, and then I can also see the tap gesture recognizer in this outline view. And once I'm in that outline view, I can open the attributes here and set the attributes for this gesture recognizer. Recognize one tap with one touch, so one finger, essentially. You could also do a 2-finger tap, 3-finger tap, 3-finger triple tap, a bunch of interesting gestures here. And now, I want to associate the tap recognition with an action on my view controller, again. And so, close this thing, we open the assistant editor, and this time I can't zoom in because it's really on the opposite size of the screen, but I control drag, again, from the gesture recognizer to my view controller, and then it says, oh sure, you want to create an action. The action is going to be called background tapped. And once I have that gesture, then finally I can start working on hiding that keyboard. But again, it was a good opportunity to show you the gesture recognition framework, which is really useful. And you can really detect complex gestures with this in a matter of not writing a single line of code, just dragging stuff around in the storyboard. So for us, this will involve saying self-note title, resign first responder, and self-note text, resign first responder. Resign first responder is Apple's way of saying lose input focus. So, you should not have input focus anymore. And this will mean the keyboard is also going away. So let me run this. And we type in some stuff here and here, and then I click the background and the keyboard goes away.
So a tap on a control is not interpreted as a single touch gesture and swallowed by the actual control you touch.
I'm touching the view that's implicitly in the background of all of these views. When I associate my gesture recognizer with a view, it's now, well, it's not shown in the hierarchy, but it is linked to this view here, the one that's at the root of the whole hierarchy.
So you could similarly associate it with a particular control.
Oh yeah, like a button. So you could click a button, tap a button, or you could triple tap a button with 3 fingers and then something else happens. You have a bunch of apps in the App Store which use very, very original gestures, like, you know, down drag with 3 fingers to delete something. So yeah, you can do really crazy stuff. And it's all really built in, which is really nice. So we have this basic UI, and then, I mean, the app doesn't actually save anything to anywhere, but it does display this one note, which is as promised. And so with the time we have left, I'd like to talk about navigation, so we can add multiple views to our application. And you'll see this is, again, very, very elegant and is accomplished entirely using the Storyboard, which is, I mean, I don't see any other mobile framework which really gives you this level of convenience. So the 2 navigation paradigms that we have in iOS today are tabs and navigation controllers. These are the 2 common ones, of course. An app can implement a bunch of different navigation strategies, but tabs and the navigation controller are 2 very common ones. So tabs are sort of like the Twitter interface again. You have a bunch of tabs at the bottom of the screen, and we have an example of this in the simulator if we look at the Photos app. In the Photos app, down at the bottom of the screen, I have 3 tabs for Photos, Shared, and Albums. And this is navigation. I can move between the tabs by clicking them. Navigation controllers are slightly different, and there's a good example of this in the settings even. So I have this master view with a bunch of stuff in it, and then when I click something, it takes me to a secondary screen, and on the top of the screen, I have this navigation prompt, which has a title and a back button, which takes me to the previous view. And this, of course, works to any depth. So I can go back and go back again and go back again until I reach the root of the navigation hierarchy. So this is a stack of views which I move between. So these are the 2 basic ways of doing navigation in iOS. And if you want to use one of them or combine them both, you can define all of your navigation in the storyboard. So once you have the views, the various scenes, you can connect them from the storyboard, and you don't have to write a single line of code to actually perform the transitions between screens. So let me show you an example of this. No, actually, I'm going to show you an example after I talk about the concept of segues. So the storyboard, as we've said, is where you put your views, where you put your scenes, the screens. Interaction between them, navigation between them is accomplished using segues. So a segue in the storyboard is simply a transition from one scene to another scene, from one view to another view. There's a bunch of built-in segues for the various navigation, for the various ways of doing navigation. For example, there's a push segue. A push segue takes one view controller and pushes it on the stack so it hides the previous one, but you still have the back gesture. On the other hand, a model segue doesn't have this back button built in. It will display something that totally hides the screen, and you have to determine exactly how to leave that second screen and go back to the previous screen. And we have many, many more. A notable example is an unwind segue, which is for navigation backwards. So you might be deep inside some navigation, and then you can go back to the first screen in one button click. You don't want to unwind the whole thing step by step. So an unwind segue is good for that. So there's a bunch of segues. This is again worth investing in further, but we're just gonna use them. We're just gonna use the more simple ones. So I'm going to hide the storyboard, I'm going to hide the outline, the assistant. This is the cleanest state I could put it in. And one thing I can do now is embed this view controller in a navigation hierarchy. So we have multiple screens now. So let me create an additional screen by dragging the view controller from the library. I'm going to drag just a plain view controller, position it over here, move the library away. To make it a bit more recognizable, I'm going to change its background. So I'm going to take the view controller and actually I need the view, yeah. And I'm going to give it a pinkish background. Now it's definitely recognizable. And now I need to link them together. So what I'm going to do is take this first view controller and use the editor, embed in navigation controller command. No code involved, of course. This does an interesting thing. It pushes a new view controller onto the screen, but this is the root of the navigation stack. It doesn't actually show anything on the screen. And it is connected through a segue to the first view controller which we actually developed. And so the navigation story has changed. The initial entry point, indicated by this arrow over there, is this navigation controller. And the first thing it's going to display is this view controller which we have worked on. And you'll also notice that in this secondary view controller, there's no room for the label anymore, because we have this title bar hiding it. And now this title bar is very useful, and you can customize its text. Like I can put some title here, like one. But the label is actually gone and hidden now, and so I have to retrieve it somehow. Let me just see how I can. Right, so no, it's not going to give me access to that label now. There it is. Okay, so this is the label. Oh, and this is the label. And I just want to grab it and move it down here. And grab this thing and move it down here. And resize this thing a bit down here. Right. Okay, so now we have this. Let me just try to see it still works. Okay, so it looks like it's still working. Oh, the save button is gone, but this is fine. I'm actually going to put that save button in a more suitable location, which is right up here on the navigation bar. So here's how to do this. I'm going to open the library again, and this time I'm going to grab a bar button item, which is like a button, but you can only place it in the navigation bar. So I grab this thing and put it here and call it save. Okay, now this is splendid, and what I would like to happen now is not only for that action to be invoked. I'd actually like this button, this save button, to transition me to the pink view controller. Maybe the pink view controller is a save confirmation, right? So, here's how. Let's hide the library again. Can you guess how to control drag, right? So I just control drag from here to here. And then it says, oh sure, what kind of segue would you like? I can have a push segue, which will embed this into the stack. I can have a modal segue, which is a bit different, and I'll show you an example of this as well. And you can have a custom segue, which means you have to define the transitions. It's much more difficult. We're not going to do it now. So I'm going to use the push segue, and then this happens. The right view controller is now also part of the same navigation hierarchy, and so it also has this navigation bar, and I can put some text in here. Confirmation. Let's run this now. Okay, I can click save, and it takes me to the confirmation pink view controller, and I can go back, and you'll notice that the back button says one note, which was the title of the previous navigation item. This is out of the box. I want to show you the model transition now. So you'll notice there's now a segue, a link between the left and the right view controllers. I can change it. I can click this thing, and then of course it highlights both sides. I can open the inspector here and give that segue a different style. I can say I want a model segue. And then I'm asked for a transition style. And I can pick from a list of transition styles. Let me show you the coolest one, which is partial curve. Okay, this is partial curve. Out of the box. Right? And how do I go back now? I mean, I don't have a back button anymore. I just flip the page. I mean, it's just crazy what you get out of the box is a bunch of presets, really. It's really pretty, this curl. I could also pick a different style, like maybe cover vertical. Okay, so this was cover vertical, and now I really don't have any way of going back. So if I needed a way to go back, I would need a button or some sort of UI gesture on this view controller, which will take me to the previous screen. And just one final thing, if I change it back to push, and go over here, there is now, as of iOS 7, a built-in UI gesture that takes me to the previous screen if I'm using navigation, and this is simply a swipe from the left, because it's supposed to, swipe this thing off the right side of the screen. And this also works, so I don't have to click that. Again, it's built in, and it's really, really strongly advisable that you do not do anything custom when the user slides from the left. The user is going to expect this gesture to just bring them back to the previous view control. Okay, so far we didn't need any code in here, but I would like the confirmation screen to actually show some details about the node that was saved. So we need to pass parameters from one view controller to the other. And this does require a bit more work. So here's what we're going to do. First, this view controller here, this scene, this view on the right, doesn't actually have any class behind it. I've dragged this thing over, and it's just the user interface. There is no class that supports this view controller for now. So I'm going to create one. Go over here and say, new file. Please give me, I need an Objective-C class. I'm going to call this class confirmation view controller, and it's going to subclass UI view controller. UI view controller is the base class of all view controllers. There are also some specialized subclasses. For instance, there's a collection view controller, which displays sort of a gallery, like the Photos app, and there's a table view controller and additional options. So I'm going to go with UI view controller for now, and we now have a new class, confirmation view controller.h, confirmation view controller.m. Now, I'm going to delete this code, which we don't really need, and I'm going to switch over to the header, and I'm going to add to this confirmation view controller a property of type and a string, which is just a string, and I'm going to call it node details. Now, I haven't talked to you about the property attributes that you can put in the parentheses here, non-atomic and strong. In a nutshell, non-atomic means this property is not thread safe. And why would it be thread safe? Well, if you don't specify non-atomic, the default is that whenever you access that property, there's a lock involved. And it only applies to properties. You don't get that for methods. So it's not like everything is thread safe by default. And this is why almost everyone uses non-atomic for all of their properties. You really don't need this thread safety to be there implicitly. Strong means this property is going to hold a strong reference to whatever object you put in it. And strong reference means it affects the reference count. You can also use weak properties, which means the property doesn't affect the object's reference count. So the object could die while the property still has a pointer to it. And this is useful for breaking cycles. There's more to be said about this, but let's just live with that for now. So we have this confirmation view controller, which has a nice property for the node details. We now only have to pass that info in from the previous view controller and to display that info inside the confirmation view controller. So let's do the second part first. Once I have this, no, actually let's do the first thing first. Right? So, if I want to transition between two view controllers and pass parameters as part of a segue, I override a method on the source view controller called prepare for segue sender. This is a method which gets called before a segue is executed. Again, a segue is just a transition from the first view controller to the other. So whenever a segue is going to happen, this method will be invoked and will give me the opportunity to customize whatever's happening and of course pass parameters. And so let's just do this. I'm going to open the original viewcontroller.m. This is the one with the first responders and the title and the text. And I'm just going to add another method here. Prepare for segue sender. Okay, so again, this is this weird double parameter syntax. I put it in the wrong place. Should be inside the implementation, of course. And I've deleted the end. There we go. Okay, so prepare for segue sender takes two parameters. The first one is the segue that's going to take place, UI storyboard segue star. And the second is the sender, the UI view that initiated this segue. In our case, what's the sender parameter going to be? The button, right? We have a save button that takes us to the second view controller. This is it. Right, we don't actually need the button here. What we do need is the segue. Now, this segue has a property called destination view controller. The destination view controller is the one I'm transitioning to, right? It also has a source view controller, by the way, which is myself. So, the destination view controller, we know, is of type confirmation view controller star CVC. This cast is actually legal because destination view controller, in fact, returns an ID. It's a property of type ID, so it's assignable to anything. However, the compiler doesn't know what confirmation view controller is, so I have to import it. Right, so now Xcode knows that confirmation view controller is a class. And once we have that, I can say CVC stop. Okay. CVC node details equals self node title text or something. So I'm passing data through by just grabbing the destination and doing whatever manipulations I need. There's one interesting thing to discuss here. I mean, this is a single method, prepare for segue sender, but I could have a bunch of segues happening. I could have a save button that takes me to one view controller, a back button that takes me to the previous view controller. So how do I know which segue exactly I'm working with here, right? I could have a bunch of different segues. So it's pretty ugly, the story here. As always, you need to set something in the storyboard to have to refer to in this method. And what I have to set is the segue's name, identifier really. So here's the segue. This is the transition from the left to the right view controller. And in the properties over here, I can give that segue an identifier. So let's call this thing confirmation segue. And now, if I go back to my code over here, I can be really defensive and say if segue dot identifier is equal to string confirmation segue, then I'm going to do all of this. Otherwise, it's some other segue which I do not recognize, and so we are not doing this.
So if you change your storyboard, that's going to be a real pain in the butt, right?
Yes.
Because everything is completely interconnected.
Right. On the other hand, I mean, you do really only have one source of truth here, which is the storyboard. And yes, you do need this hard-coded constant in your view controller. I don't think it's that bad. There's no real reason to change your segues identifier later. What is important, though, is that if you have multiple storyboards, and you can have multiple storyboards, you will need to make sure that if you reuse the same view controller, you also reuse the same segue names. You're asking yourself, why would I have multiple storyboards? And the answer is, if you have a universal application, you will have a storyboard for iPhone and a storyboard for iPad. And you can still reuse the same view controller class, but this is one place where you have to make sure you use the same segue identifier. We're not going to actually do this now. So we only have a few minutes left. Let me just get this working. We have the left side. We're passing in the node details. We just need to display them in this new pink confirmation view controller. Now, in that pink confirmation view controller, I currently have no methods, and I also have no UI. So let me go to the storyboard and put something like maybe a label in here. Here's a label. Drag it over here. Center both ways. Let's make it a little bigger and stretch. Stretch and center. There we go. Okay. Now, to reference that label from my second view controller, I need an output. Okay? So we click this view controller and we use the assistant editor, and it opened the wrong thing. It opened the view controller class and not the confirmation view controller class. Well, there is a good reason for this as well. I haven't told anyone that the new class called confirmation view controller actually has anything to do with this thing here on the storyboard. They are not linked. I have this thing here, I have the class over there. Need to tell them that they are linked. So here's how. I just click this view controller, and one of these buttons over here opens an inspector called the identity inspector. This is really important sounding property sheet. And here I can say the class for this thing you see on the storyboard is actually a class I have in my project called confirmation view controller. So this is the length. I know there's lots and lots of magic involved, and I mean, the storyboard story is really about working super hard so that you don't have to instantiate all of these objects. So you don't have to create the left view controller and the right view controller and link them together and define the transitions. On the other hand, it does mean there is, again, this magic where you set something in a weird place and then something works. Anyways, if I click the configuration view controller now and use the assistant editor, it still opens the wrong file, but oh, here's why. It's set to manual. If I use automatic, then it says, oh yeah, sure. These are the files I should have offered you. So confirmation view controller.m is the one. And now we want to link them together. Label goes here, control drag, and let's call it confirmation text. Final step. We have this pink view controller class, confirmation view controller. It needs to actually set the confirmation text. Now, one pretty compelling option would be to do the following. We already have here. Sorry. We already have here the node details property. So we could just say, whenever you set node details, we also set the title of that label in the UI. We change the outlet itself. And this will not work, unfortunately. And the reason is the following. We set this property from our view controller on the left. This is the line that tells the view controller on the right what the text should be. When this line runs, the view controller on the right is not displayed yet. We're still preparing for that segue, preparing for that transition. It's not displayed yet. And its outlets are not initialized yet. The view controller itself exists. The Objective-C object is there. But the outlets are not connected to the view yet because the view has not been displayed. So I just can't use the property setter to change the outlets. And this means we're going to introduce a new concept, a method on confirmation view controller called view_did_appear. And this V here doesn't belong. This is a simple life cycle event which is invoked. This is a method, of course, which is invoked whenever the view shows up on the screen. So we could. It's not load, it's appear. There's
if you open it, we see shot.
Oh yeah, no, it's still not page load. No. The issue here is the following. This same view controller could appear and disappear multiple times. I mean, I could get myself into that view controller, navigate backwards, it doesn't go away, then go back to that view controller again, maybe switch to a different tab in my application, then switch back. It's not loaded again and again. It only disappears and appears. And so what we want really is view_did_appear, because it will only be loaded once, but it may appear like 100 times. So in view_did_appear, which is the lifecycle event that gets called whenever the view controller shows up on the screen, we need to set that outlet. So self.confirmationText.text equals self.nodeDetails. And then we finally have this hookup done right. If I run this, I can put in a title and click save, and it takes me here. You can actually see the label appear for a split second before it was replaced with by flowers. Of course, I can just delete that label text and just keep the by flowers over there. I do have time for one final thing, which I want to show you, again, to make this slightly more interesting, which is animations. This confirmation label appears in a pretty boring way. I mean, it just sort of pops up on the screen. Instead, it could be more interesting if it maybe faded in, or flew in from the bottom of the screen, or twirled and then just stayed in one place. So I'm going to go with fade. I'm going to fade this label in. So the way we do that is by first, on the storyboard, setting up that label, this label over here. I'm going to set it up to have alpha 0. So it's completely transparent. And then we're going to fade it in. And of course the text, I'm going to delete the text. Okay. So it's not here anymore. Going back to the view controller, right here, I set the text, and then I want to animate the fade, the alpha property. And here's the way it's done in iOS. In fact, there are two different animation frameworks. A low-level one called Core Animation, which is super hard to use, and a very high-level one called UI View Animation, which is really easy to use. And here's how you use UI View Animation. UI View, animate with duration animations. This is the function that we're going to use. There's a bunch of overloads, but animate with duration animation basically says, here's the animation duration, here's the animations to perform, do it. So animate with duration takes an NS time interval, which is really just a simple number. So let's just put 2.0 here. This is 2 seconds. And animations is this weird looking thing with the hand. This is a block. It's again part of syntax that was introduced in iOS 4 to Objective-C, and it's basically a function pointer that can also capture state. So it's like a lambda function, or an anonymous delegate in C#. So if I just let Xcode autocomplete this thing for me, it generates this body, this function body over here. The hat says it's a block, it's a lambda. And then there's a parameter list, which is empty, we have no parameters. And then the function body itself. So inside the function body, we just do the following. Self.confirmation_text.alpha equals 1.0. It used to be 0, now it's 1. This is all. Okay, let's check it out. By flowers, save, and it's fading in. So this is animations, seriously. I mean, there are quite a few properties which you can animate using this very, very simple API. You just pass in a function which sets these properties, and the view system makes sure to animate their values for you over the specified interval. And this works for alpha, for the frame, which is the position of and size of the view on the screen, so you can have things fly in or zoom in and out. This also works for adding views to the screen and removing views from the screen. So it really works for the basic scenarios. Now, if you need something super pretty, like a rotation that brings the view in from one side of the screen and then changes, I don't know, other views' positions as well, you might not be able to accomplish that with the simple view animation framework, but in many cases this just works and does all you need. So now we have also animation working in our app. So let me just try to wrap this thing up. We've seen a bunch of examples and quite a bit of code and concepts here. But I mean, I think you are now convinced that Objective-C, Xcode, the UIKit framework that we've been using, I mean, there's obvious differences from other frameworks and languages, but there's also lots and lots of similarity. You're still working with a UI designer where you can shape up your views and transitions without writing code in a visual way. You still have code behind. You still have view controllers, which you connect in both ways to your views using outlets and actions. You still have animation. You still have data passing from one view to another. There are some details which we haven't gone into, like data persistence. You can store data in files, in a database, accessing the web, more complex UI controls like lists, which have a dynamic number of elements. But I think for maybe 5 minutes, this was pretty good in terms of coverage. Now, obviously, there's a lot more to learn, and if you need additional references, really any help with getting into iOS development, these are my contact details, and I'll be happy to help and point you out in the right direction. So this is my Twitter handle and my blog. If you're coming to my Android workshop tomorrow, say hi, and I hope you've enjoyed DevWeek so far. Enjoy the rest of it. If you have any questions, come forward. Thank you very much for coming. Thank you.